Um, Good day, everyone. I welcome you all to my class this morning. I'm reaching out to you from Edwin School, Ekbang. I remain your chemistry teacher, Mr. Moshe Chong. And this morning, we'll be looking at problem solving in chemistry. Actually, what I'm going to be doing for you is just to guide you on how to go about solving problem. Right, and this morning we'll be looking at this question. And what is the question? So, to what temperature must a gas be raised from 273 Kelvin in order to double its volume and pressure? Now, for you to know the appropriate formula to use, just look at the parameters that are given in the question. Now, we have temperature, we have volume, and we have pressure. Now, that tells us that the formula to use is the general gas law, which is the combination of Boyle's law and Charles' law. I'm not going to derive the formula for you this morning, but I'm going to apply the formula to solve the problem. And this is the general gas law. P1 V1 over T1 is equals to P2 V2 over T2. Okay, where pressure is P, volume is V, and T stand for temperature. Now, what are we expected to do here? We're expected to find the temperature. Of course, the initial temperature is given as 273. Okay? But we're expected to look for T2. So, how do we do that? Let's cross multiply and make our T2 the subject of formula. So, when we cross multiply, what we have is P1 V1 T2 from here. Okay? Which is equals to P2 V2 T1. So what do you do to make T2 a subject of formula? By subject of formula, I mean to stand on its own. We divide all through by P1 V1, okay, by both sides by P1 V1. By so doing, these two will cancel and your T2 will be left alone. So that's what we mean to make something the subject of formula. So what we have here P2 V2 T1 over P1 V1. Okay, so let's go back to the question and extract what is given from the question. Now they say, to what temperature must a gas be raised from this temperature? This is the initial temperature. So the initial temperature there is T1 is what? 273 Kelvin. Okay? So the volume and pressure, they are at initial state. But what are we going, what would be the final state of the volume and pressure? So we're going to look at P2, which is 2P1. Because they say for something to double, it means 2 times that parameter, which is P1. So for volume to double, we have 2V1. Okay, so let's substitute what we have here into this formula. So our P2 is 2P1 times V2 is 2V1, T1 is 273. Okay, so divide by P1 V1. Okay, when you divide, okay, we have P1 up and down, so we can cancel out, and also V1. So what we are left is 2 times 2, which is 4, times 273. So let's multiply 4 times 273. 273 times 4. Okay, 4 times 3 is what? 12. Take 1. 4 times 7 is what? Is 28. 28 plus 1, 29. Write down 9, carry 2. 4 times 2 is 8 plus 2, 10. So our final answer will be 1092 Kelvin. So this is our final temperature, right? So at this moment, I'll stop here. Then subsequently we'll be looking at other areas to cover. So I still remain your chemistry teacher, Mr. Mishima. Bye for now.